The first form of the trebuchet was invented in China in 300 BC. This first form of the trebuchet was mostly made by manpower.
The traction trebuchet that was powered by men was then replaced by the counterweight trebuchet, which had weight at one end and then it had your projectile at the other. And basically when the thing that was holding the projectile was cut or released or whatever, the weight from one end would go down as the projectile would launch.
Trebuchets used counterweights of 20,000 pounds to launch a 300-pound stone as far as 300 yards.
So this is our trebuchet with the dimensions of 1 foot by 2, and this is our 40-inch pole stick, and at one end that where it's holding all the weight is held by a toothpick and some fish hooks, and on the other end is 20 pounds of weights held by string, and this is our stick that supports it, so for when it's released it swings like this. And the way how we cut it is we use a string to rip it, and basically when it does that it flings and it launches the projectile.
Weights are held by the arm. There's tension between the two ends. As the arm is held by the toothpick on the other side, the potential energy of the weight is at its maximum. And when let out, all the potential energy is converted to kinetic energy for the projectile. The projectile end is then gaining potential energy into the air after it's released.
The trebuchet launched the baseball at a distance of 4 meters in 2 seconds. In order to solve for all the variables within the equation and how to solve for each one, we would need to use a one-dimensional projectile equation. We already have how far they went and how long it took. So in order to get the initial velocity for x, we would have to use the x equals v naught t plus half a t squared formula. X is 4 meters, which equals v naught. Vx is our variable, and the t is 2 seconds. This half of the equation gets cancelled out because acceleration equals 0 in the horizontal direction. Next, we would have to isolate the Vx, so we would divide 2 seconds into both both sides of the equation, and we would get 2 meters per second equals the initial velocity of x. We will be figuring out the initial velocity of the Vy. In order to do that, we will be using the V equals V naught plus AT formula. The V will be 0 at its maximum height. V naught is unknown. Acceleration is -10, and then it's going to take 1 second to get up there, which was half the time it took to complete the whole thing. Which will equal 0 equals V naught plus -10. After you multiply, you add 10 to both sides, and 10 meters per second is your initial velocity in the y direction. After that, we will be using the x equals v naught formula to figure out the height, the maximum height. For x, we'll be plugging in y equals the v naught for y, 10 meters per second, 1 second plus half, -10 for gravity, and 1 second again. It's 10 plus -5 times 1, y equals 10 minus 5, and the maximum height was 5 meters. For step 3, we'll be figuring out the angle of the projectile. We will be using tangent of the angle to the -1 equals 10 over 2. We will multiply both sides by 2, and you end up with 2 tangent of the angle to the negative 1 equals 10. When we plug that into the formula, 2 times 10 to the negative, I'm completing, and you get 1.107 equals 10. Then you divide by 10, and you end up with an angle of 22 degrees.
2, 1.